Hello viewers, in today's class we are going to discuss one very important and conceptual limit in differential calculus, right? So here we have to evaluate this limit when x tends to 1 plus. This positive sign shows that we are approaching towards x is equal to 1 from the right of x is equal to 1. So all the values of x which falls towards the right of x is equal to 1 are greater than 1, right? So this point is important while evaluating this limit, right? And moreover, here this positive sign shows that we are evaluating the right hand limit of this function when x approaches towards 1, right? And here we also see that we have the combination of three very important functions in mathematics, that is the signum function, the mod function, and the greatest integer function, right? So here we'll make use of the definitions of these three important functions while evaluating this limit, right? So let us start. Now let us first call this limit as L, right? And here what we will do, we'll take x is equal to 1 plus h, right? So x is equal to 1 plus h, and h is a very small quantity and h is greater than 0, right? This is also a very important point in limits, that is this quantity h is a positive quantity, but it is very small, right? So when x tends to 1, then obviously h tends to 0, right? So we'll now take x is equal to 1 plus h, or we'll replace x by 1 plus h in this function. So now this limit L can be written as limit h tends to 0, and we have 2 times of signum of x plus 3, right? So this is the signum function, and we'll also take or we'll also see the definition of signum function in the later part of this video, right? So we have 2 times of signum of 1 plus h plus 3, and here we have the mod of 1 minus here we have x is equal to 1 plus h, so we can write it as minus 1 minus h, right? And here the square of greatest integer of x plus 1, so we have 1 plus h plus 1 and square, right? So this is the square of greatest integer of 1 plus h plus 1, right? So now we can write limit h tends to 0. We have 2 times of signum of h plus 4, right? This is 3 plus 1 4, and in the denominator we have 1 and 1 get cancelled, so we are left with mod of minus h. This can be written as positive h, right? So here we have h, and here this is greatest integer of h plus 2, right? See, 1 plus 1 is 2, so we have greatest integer of h plus 2, or we can also write it as greatest integer of 2 plus h. So as we have said that h is a positive quantity, right? So and this h is very small, so when h is added to 2, obviously 2 plus h is greater than 2, but it is less than 3, right? So h is very small, so when we add h to 2, we'll get 2 plus h, and 2 plus h is slightly greater than 2, but it is less than 3. So therefore, by definition of greatest integer function, 2 plus the greatest integer of 2 plus h is simply 2, right? So here we'll write 2, and this is 2 square. So now we can further write it as limit h tends to 0. This is 2 times signum of h plus 4, and here we have h plus 4, right? Now we'll take h is equal to 0 because h is tending to 0. So we have now 2 times of signum of 0 plus 4, right? 0 plus 4, and here we have 0 plus 4, and this is 2 times signum of 4, and here we have 4, right? So this is 2 2s are 4, so we have half of signum of 4, right? So the value of this limit L can be taken as this expression, but here we'll express it in some other way, because we know that the definition of signum of say y, signum of y is defined as positive 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is minus 1 whenever y is less than 0. So this is a very important definition of signum function, right? And this definition is useful while simplifying any expression containing signum function, right? So here we see that we have this expression that is signum of 4, that is signum of 4, and we see that this 4 is greater than 0, right? And see the definition of signum function. Signum of y takes the value plus 1 whenever y is greater than 0. So here y is 4, right? So y is 4, and obviously 4 is greater than 0. So signum of 4 will take the value plus 1, right? So we'll take here plus 1, so we have half times plus 1, so this is simply half, right? So viewers, the value of this limit, which is a combination of signum function, mod function, and the greatest integer function, is equal to half, and this is how we solve this important limit.